Let's wait for a few minutes for people to come in. Okay, can someone let me know if they're seeing the right screen or the wrong screen? Are you guys seeing the one with 2 slides or one with 1 slide?
2 slides.
Okay, that's terrible. Let's see, how do I cancel that? That's fine, it's not a big deal. Let's wait for 4 more minutes. And let's try something fun. I don't know if that works. Let's see. Actually, you know what? I don't think it works with screen sharing, does it? Does this work? I don't think it does. Let's wait for 1 more minute. 2:05 will get started. For those of you with the video on, I do appreciate that. You get to appreciate it more when you're teaching, not so much when you're a student, but you know that's the way it is. Thank you. It's not strictly necessary, but I do appreciate the gesture. Okay, let's get started. So welcome to ITP-356. You are in the right class. It's this class we're going to learn about the decentralized applications in blockchain. So the end game of this course is for you to be able to have a relatively comprehensive understanding of the process to create a decentralized application on Ethereum, and also even have your own dApp created with the smart contract written in Solidity and the front end written in HTML, CSS, and JavaScript. And I know that not everyone has programming experience, and that's totally fine. There's going to be a lot of hand-holding in the beginning. We're going to go real slow. And if you've seen the syllabus, and we're going to go over it in a bit, if you've seen the syllabus, then you might see there are, I think, 7 homework assignments. Don't worry too much about it. I have so many because I want to split them into smaller ones so that it's easier for you guys to grasp a specific concept instead of throwing too many concepts at you at once, and that might be overwhelming. So and at the beginning, you're not going to start coding from scratch. It's kind of going to be like filling in the blanks, and as we go along, there's going to be less hand-holding, and hopefully by the end, you'll be somewhat able to write your own decentralized application from start to finish, more or less. All right, so let's get started today. Our very first lecture. My name is Jack, for those of you who don't know me, but I suspect most of you do know me because you all took 256, I'm guessing, a while ago. And this is actually the first time we're offering 356 in a while. It was only offered as a 499, I think 2 years ago, I can't remember, by a different instructor. And since then, they weren't able to find anyone to fill the spot. So here we are. Really excited to teach this class. Again, my name is Jack. I just graduated with a master's degree from USC, computer science major. So before we get started, let's do some introduction, tell you a little bit about myself. So who am I? So I got my bachelor's and master's degree from USC in computer science. I've been, if you're a CS major, you've probably seen me around because I've been the TA for quite a few computer science classes. I TA for 201, which is Professor Miller's class. He's now the director of ITP. He used to teach the Java class in CS department. And then I also TA for ITP-116, which is also Professor Miller Python. 256, the Bitcoin blockchain class taught by Chaz. And then also 342 and 344, which are iOS classes. So I actually started, when I first started doing programming, actually I was doing iOS. And I've been doing Solidity development since 2019. Sorry, against the advice of many of my peers, in which they said it was just all a scam. But obviously it probably isn't, or maybe it is, but I like to think that it isn't a scam, right? So I've been writing smart contracts for a while. I co-founded my own startup, blockchain startup with 2 other co-founders. It's called Eaststein. So you can think of more or less DocuSign on Ethereum, but there's more. So we actually also provide DAO tooling and a bunch of stuff. I'm not going to get into it. So we have, so it's going pretty well. And some other fun facts about me, about myself. I wasn't always a CS major. I used to be a film major. I used to be a digital arts major at Chapman University's film school, and Chapman's in Orange County. So I used to be a film student before I transferred to USC. Apparently, and the second fun fact, I don't even remember this, right? So my dad actually told me a couple of weeks back, he told me that apparently when I was in middle school, so like what, 6th grade, and that's what, 7th grade, I think that's like 2010. Apparently I was urging him to buy Bitcoin back then. I don't even remember that. But he told me, but he was very adamant about it being true. So that must have, it's probably true. But I don't remember everything from back then. But apparently in 2010, I was urging my parents to buy Bitcoin. My dad dismissed it as a scam. And look at where we're at now. Right. So that's enough about me. I'd like to learn a little bit more about you. I see a lot of familiar faces, but why don't we do a brief introduction, everyone? So just your name, major, class setting, so what year are you, and also why are you interested in this space, and what do you hope to get out of the class? Yeah, so we can anyone can just pop up and talk about it. We have any volunteers?
Hi, everybody. I'm Jared. I'm a senior, a real estate development major, and I'm taking this class because it's a continuation of the blockchain class that I took with Chaz Hales. And I'm excited to learn about Solidity smart contract coding. Yeah.
Welcome, Jared.
I can go next.
Yeah.
So my name is Dylan Patterson. I took 256 as well, like last year. I'm really interested in Ethereum and mostly decentralized finance, and I'm also really excited to learn Solidity. Like I've been taking some programming courses outside of major to try to literally only try to learn Solidity. So I'm really excited to see what we can do.
Yeah, we're gonna work on a lot of cool projects this semester. Homework assignments. It's gonna more or less blow your minds. Hopefully not your grades. All right, anyone else? Any other volunteers?
Yeah, sure. Hey guys, I'm Cameron, and hey Jack, good to see you. Yeah, I'm a senior. I'm from the Bay Area, business major and blockchain minor. Obviously, I took it with 256 with Professor Hales. And the thing I love the most about the future of blockchain is smart contract capabilities and what that's going to do for the world of investing. And we've already seen it with NFTs. So I'm just really excited to code as well. So yeah.
Thank you. Thank you. Anyone else? No extra credit is given, but it's good to, yeah, Nicholas, let's go.
Yeah, hey everyone, I'm Nicholas. I'm a senior, finishing my last semester as a CS major. I've been into crypto for quite a while. I actually have built one dApp before that's live right now in Solidity, but really just looking to take this class to learn more and kind of build on the knowledge I have. So looking forward to it.
It's good to see you. And there's a lot of, oh, Chase, let's go.
Hey, I just want to quickly introduce myself. I'm Chase. I took the blockchain class last semester, and I was just really interested about the amount of different problems that arose that were basically invented by the creation of Bitcoin and then going into Ethereum to see how it can even get more developed. So I'm also interested in the challenge of kind of creating all this stuff myself because I've had any coding experience. So I'm excited for the challenge.
Great, you're going to be in for a treat. It's so much different from conventional programming. It's pretty crazy. Armand, let's go.
Yeah, I'm a philosophy major, but I think it's good to follow your curiosity, and so that's what I'm doing. I took 256 last semester, and I really enjoyed it. So.
Are you a blockchain minor, or are you just taking?
Yeah, I picked up the minor.
That's cool. That's cool. We're gonna work on offering more classes in the minor. So hopefully everyone can graduate on time. Everyone who's enrolled in the minor. All right, Nick.
Yeah, hi everyone. I'm Nick. I'm a business major, and then I'm a senior as well. I took the blockchain class mostly because I was interested in like not the cryptocurrency aspect of blockchain, but kind of like the decentralized application aspect of it. So yeah, I kind of took it on a whim, but like really enjoyed it. And then I've been meaning to take this for a year because, yeah, like you said, it wasn't offered. So really excited.
Great to have you, man. Ben, I love your profile picture.
Oh,
you had your hand raised.
Yeah. Hi, my name's Ben. I'm a junior. I'm majoring in cyber operations and intelligence and minoring in blockchain. Really excited for this course to kind of learn how to build more. Yeah, I kind of just mess around on DeFi, do some DeFi plays at the moment, but nothing crazy. Yeah, super excited.
All right, cool. We have anyone else? Jacob?
Hey, my name is Jacob McPhee. I'm a senior real estate development major. I've been fascinated by crypto for a little bit over a year now. And I took my only coding experience thus far has been ITP-115. And I wanted to get in this class last semester, but it was canceled. So definitely going to need some refreshing as far as programming goes, but I'm really excited to learn.
Yeah, no worries. We're going to start from scratch. You're actually already more ahead because I have to explain what variables are. But I see Terry's laughing because I know he's a EE major, right, Terry? Terry, I can't hear you.
Oh shoot.
There you go.
I'm a CS major. I switched from EE to CS in freshman year. Hey guys, my name's Terry. I'm a junior computer science major. I'm into robotics and firmware stuff. I'm interested to see if blockchain and decentralization play into that field.
All right, good to have you. Maya, I know you from last semester.
Hi, yeah, I'm Maya. I'm a sophomore here. I'm majoring in physics and computer science, and I took 256 last semester, so I'm interested to learn more about Ethereum, and yeah.
Welcome back. Mike, Sean, who wants to go first?
You got it, Mike.
Thanks, Sean. Yeah, hey everyone. I'm Mike. I'm a econ major in data science. On the side, I help out Jack with his project ETHSign, and excited to learn more about Solidity development and more about Ethereum.
Yeah, Mike's in charge of our community operations, and he's pretty good at it. So yeah, welcome, Mike.
Actually,
I hope you don't hate me after this class.
you better not fail me. And also on the side, I also am the VP at Blockchain USC. This semester I'll be president. So at Blockchain USC, we offer blockchain education, speaker events, and career fairs. So if you guys are interested, feel free to come to any of our events. We're open to anyone, and we're taking in more e-board positions. So we have 330 members. Last semester, we did events with Masari, Chainlink, The Graph, and top protocols and projects. So yeah, excited to be here.
Thank you. Sean?
Hey everyone, my name is Sean. I'm majoring in business administration. I'm in the blockchain minor. I took ITP-356 last semester, and I've been dabbling in crypto and like blockchain in general since like 2017. So I thought it was time that I actually got a good understanding of the back end of it, and that's kind of why I'm in this class.
Cool. Welcome here.
Thank you.
Jaden?
Hey, is my mic working?
Yeah.
Okay. Hi, my name's Jaden. I'm a senior mechanical engineering student. I'm pretty invested in crypto right now. I'm really interested in several DAO projects on like various blockchains like Phantom and Solana and stuff like that. A lot of my friends are really into it, and I have a lot of CS friends, so it kind of just all lined up together, and I wanted to follow my curiosity with it, and so yeah, here we are.
Yeah, definitely. Hope you're not overly invested because the market's not doing so well this past week. Also, no financial advice here, although I'm pretty sure half of us are losing bleeding money this week, but that's fine. Colin?
Hey, I'm Colin. Yeah, coins only go up. I'm a senior. I'm a data science and cognitive science major. And I'm interested to learn more about writing decentralized apps. I've had an NFT project for about a year, and I kind of want to start building my own dApps rather than having to hire expensive developers to do it.
Definitely. Solidity developers are paid very well in this space. They're pretty hard to find. And yeah, mainly because, a lot of a lot of those who already know Solidity, who are good at it, they usually have their own projects, so it's hard to hire people.
Exactly.
All right, sorry, how do I pronounce your name?
Oh, it's pronounced Prithvi.
Prithvi?
Yeah.
Cool. Sorry, I just didn't
I'm a
mispronounce it.
senior. Yeah, I'm a senior and I'm really interested in blockchain. I took intro to blockchain like a year ago, so I'm really interested in like coding the back end of it and everything. So yeah, and like Ethereum and Solana is what I'm pretty interested in. So
Yeah, in this class, we're going to go over Solidity. So that's Ethereum and all the other EVM chains like Polygon and BSC. For Solana, they're using Rust. We're not going to cover that. I actually personally don't know how to code in Rust, but I heard they're going to have like EVM compatibility soon. So we'll see about that. All right, cool. Anyone else want to talk about things before we move on? That's about it. We're all too sad from the market. That's fine. I woke up today. I had a heart attack. I mean, I've been having consecutive heart attacks for the past few days. So that's all right. Okay, that's enough talk about introductions. Let's get into, let's actually go over the syllabus briefly. So it's posted on Blackboard. Let me share my screen. It's posted on Blackboard under the syllabus folder. Let's briefly go over this. And then we're going to do some review, some quick refresher from 256. All right. Okay, so welcome everyone again, ITP-356. So I will be your instructor. Speaking of office hours, I'm going to hold them remotely. I haven't decided on the time yet, but it's going to be 2 hours per week, but I am flexible on that. So if we have an influx of questions, I'm going to extend those. And also we have Piazza set up. So it's all under the syllabus folder on Blackboard. So basically Piazza, if you haven't used it before, mainly people in the CS department use it. So it's like an online forum where you can post questions and everyone can answer and respond to them. And the one thing I like about Piazza is that instead of you asking me the question one-on-one and then only you getting the answer, if someone else also has the same question, if you post on Piazza, then everyone can see it. And then when I answer it, it can benefit multiple people. And you're also able to post anonymously. So if you're shy, which if like I used to be a student, right? So nobody wants to look stupid, but you can post anonymously, so no one else can see them. But so no one else can see who you are, but I can still see who you are. So but that's fine. I love you all equally. No, so there was someone actually in one of the CS classes I took. They didn't realize the anonymity doesn't apply to instructors. So for us, we can still see who's posting the posts. And that person was just like pretending to be multiple people and then responding to his own post. I thought it was funny. So make sure you don't make that mistake. But please be sure to post on Piazza. Don't be discouraged to ask questions there. It's going to benefit everyone. And we're going to have a TA, Jordan Bencourt. He also helps out at Eaststein, and for him, he's going to help out with mainly JavaScript and general programming questions, right? So he's going to have he's probably also going to have 2 to 3 hours of office hours per week. And at the beginning, there might not be a lot of questions for him. So any Solidity questions, you should come to me for that. But towards the end, we're going to start building our web app with JavaScript, doing HTML. And don't worry, we're going to give you templates. Like we're not going to start from scratch. But when we're doing that, Jordan, he also knows a lot about that. So he can answer your questions there. And we have our emails. You can email us. I know I've been a little bit slow in responding to emails. So emails mainly, if you really want one-on-one help, you can email me. And I'm happy to help, right? But if it's a more if it's a question that's not super personal, then I prefer if you post it on Piazza so everyone can see my my answers. Or in some cases, right, it's a crowdsourcing platform, so maybe other people already know the answer and they can spread the knowledge that way, right? So we're going to skip over the course description. We're just going to basically by the end of this course you're going to have an idea and some of the skills as to how to build a complete dApp or decentralized application from the start to finish, right? So obviously prerequisite 256. There aren't any co-requisites. So I do have a recommended preparation, and I'm going to talk about it in a bit. So I'm going to talk about it right now, actually. So we're going to get into programming on week 5. All right. So, and of course, this class, because it doesn't have any programming prereqs, I can't assume everyone already knows how to program. And I am going to start from scratch, right? I'm going to start to teach you what variables are, what functions are, this and that, right? But you're going to have a much easier time, not just on week 5, but all the weeks following week 5. If you kind of get started on your own, get a head start, just to kind of get yourself informed and somewhat familiar with the lingo of programming, like what are variables and what does code look like, that kind of stuff. Like I'm not asking you to become an expert programmer by week 5, like an expert in JavaScript. That's by no means what I'm trying to do. I'm just trying to make it so that you have more context coming into the class starting from week 5, and it's going to benefit you tremendously if you come in with some knowledge, right? So we also have some extra course information. Now this is interesting. So this is a separate write-up that I did. We're going to talk about it in a bit, but let's just keep going on the syllabus. So course notes, I'm going to post everything on Piazza, Blackboard, all my slides. I usually post them ahead of time. I believe the slides for today are already up there. Even the slides on Wednesday are up there. And you guys can get the slides ahead of time and notify me if you see any errors and whatnot. And the recordings obviously will be available on USC Zoom Pro. Yeah. And also, and next, something about hardware and software required. So because we're going to write code and do stuff, right? So basically everyone has to set up their own development environment on their computers. Now, if you're running on Mac OS, it's easy because Mac OS is somewhat, it's a pretty unified environment, and setting up everything is relatively straightforward if you're using Mac OS. If you're on Windows, it's a little bit more complicated because we have different Windows versions, and within the same version, you have like different path environment. Well, not path, different path, the path is the same. But the environment setup basically is very complicated in Windows. So what I did was basically I created a Linux virtual machine for all my Windows users, all of you Windows users out there. So you can actually download it and run everything in Linux. And I have the instructions in this link that we're going to go over in a bit. All right, so so we're going to talk about that, and also require readings. These two are basically just documentation. Who reads documentation, right? You only read documentation when you need help. But this Mastering Ethereum, this is a little bit more structured. This is basically the book that we're going to loosely go off of. That's what kind of guides the material, more or less. So the author, Andreas Antonopoulos, he's very, very knowledgeable. He's one of the OGs. He's like a Bitcoin evangelical person. He's really good. I actually bought both Mastering Bitcoin and Mastering Ethereum, and afterwards I found out they can be downloaded for free. So this is a link. This leads you to the official GitHub page. So this is not pirating. This is the official GitHub page for the book that you can read. And we're gonna have basically chapters per week that you can kind of go ahead and read it. You don't have to read it, but you can get a lot more context if you do read it. All right. And also let's talk about this assignments, right? So it says most homework assignments, homework's computer-based. I would argue that they're all computer-based. So this semester, we're using something called GitHub Classroom, and we're going to get to it in a bit. Basically, it's not Blackboard that you use to submit stuff, because mostly we're going to be submitting code. I think everything after homework 2 or after homework 1 are some kind of code assignment. So we're going to use GitHub because GitHub is it's basically a how do you call it? It's like a code repository thing that we CS people use. And don't worry about it. I have tutorials for everyone. It's very easy to get set up. And all the homework assignments are due exactly at the beginning of each week. So it says, or I wrote, e.g. an assignment due on week 2 is due on week 1, Sunday, 11:59. So what does that mean? So if we scroll down to the schedule here, you can see that I have written homework 0 due on week 3. Now, what it really means is that homework 0 is due on the Sunday of week 2 at 11:59 p.m. All right, and that's automatically enforced by GitHub. And once it closes, you can't really you can't turn it in anymore. And because later on, because we have code reviews in class, basically I'm gonna, if you're willing, we can look at your code and see what's wrong with it, and what's good, what's bad. So we're gonna do some code review in class. And because we're doing that, we can't really have late days, because otherwise you can just not do anything and then turn up to class with nothing, right? So we're not going to have late days, but I have everything. I have all the schedule ahead of time, and you can let me know if you don't have enough time and we can adjust this, because again, this is more or less the first time this has been taught by me. And I'm writing everything from scratch. So let me know if the difficulty is too high, and we can, if a lot of people think it's too hard, we can do something about that, right? Like, I am very flexible on this. Exams are open book. They're open book because more or less, I don't, because I think this is one of those things where if you know, then you know, but if you don't, you can't really Google it. And actually I'll change this. I will make it, actually, I'm not sure. Do I make it open Google? I'll make it open Google. All right, but there's no communication. And let's not worry about the Zoom recording part, because we need, I might just drop that because privacy concerns and whatnot. But the point is, the exam will be open to everything, but you can't talk to each other. I think that's pretty fair, because in the real world, you can go, I Google stuff all the time, right? So there's no point in kind of restricting you to anything. And the exams will be written in a way where you can't easily just find answers. You have to understand the material to get it. All right, so the homework assignments, we're gonna have a lot of them. I think, let's see, we're gonna have 7, which is not gonna be a final project. We're gonna have 7 assignments. They're worth 40%, midterm 30, final 30. They added to 100. All right, and the grading scale, this is just a standard grading scale. As for curving, I am open to it. Although, we'll see what happens as the course goes on. If everyone's struggling, if things are too difficult, I'll adjust the course based on feedback. So this is all still negotiable. And assignment submission. So basically, no late days. They have to be on time on GitHub Classroom, right? And grading, we're going to try to get it completed 7 days after submission. Although right now I only have 1 TA. I'm trying to hire another, and when we have 2 TAs, I think 7 days is pretty reasonable, right? And again, just no talking to each other during the exam, right? And well, it says that, and also no makeup exams unless you have some emergency that you can email me and we can set up something one-on-one. For the time zones. I'll think about it. I will think about it if you're in a different time zone. All right. Okay. So our course schedule. So week 1, which is this week, we're going to review Bitcoin, and then we're also going to do some intro to Ethereum. And then homework 0 is basically some environment stuff. I'll show you in a bit. And in week 2, we're gonna kind of do some introduction into dApps, what they are. Week 3, what is Web3? You hear this all the time, Web3, but what is it, right? What is Web3 and how do tokens work? All these kind of issues. Week 4, we're gonna start dabbling in development stuff, but this is mainly just an introduction to the development environment to help you kind of set up for week 5, where we actually start to learn about the code and we start to code stuff. Week 6 and week 5 is more, it's not about coding, it's more like conceptual things, key terms in the language. Week 6, we're going to actually start writing code. And week 7, more about the language. Week 8, we're going to do some code reviews in class. And you see a bunch of like smaller assignments. And these are all very, very, very incremental. And you're not expected, right, to start writing them from scratch. All right, so I will have like a skeleton ready, and you can just fill in the blanks gradually. All right, and gradually, the skeleton will be taken away, and hopefully you all learn how to write things on your own. All right, and week 9, we're actually gonna deploy our first contract, although like it's probably gonna be a pretty trivial one, like a counter or something, right? But nonetheless, we're gonna deploy it onto a test net. So that's when you're gonna first see your contract actually on the blockchain. And week 10, we're going to talk about some security concerns. Week 11, some optimization stuff, and also how to test if your contract works correctly. We're going to have another code review. Week 12, we're going to actually write a UI for your dApp, so a web page, and also this web page will be given to you as a template. You just need to fill in some of the blanks. All right, and this is not a web development class, so I'm not expecting. To be honest, I'm not even that good at writing web front ends. Jordan's very good at it, so we're gonna have it ready for you, and you don't have to deal with too many of these. You just have to recognize what's what and how to manipulate them. You don't have to write them from scratch. All right, and week 13, we're gonna talk about some of the infrastructure work in Web3, and also some of the more philosophical questions regarding, not philosophical, but just more topics on decentralized applications. And you see the homework due dates at first are due basically the week after, but more or less the week after. But as time goes on, we kind of see the due dates getting spaced out more and more. That's because the assignments get progressively more difficult and more complex. And again, let me know if I'm taking things too far. But the idea is we're gonna start building off with some really easy assignments, and then gradually we're gonna let go of your hand. And for homework 7, you're basically gonna build out like a full-fledged, not build out from scratch again, but you're gonna build out like a full-fledged decentralized application that people can use with a web front end and everything. And we're actually going to have an in-class workshop or lab where we can work on stuff. It's basically like an extended office hours, more or less, or we can talk about, or it could be like a public forum where you can submit questions beforehand, and I'll answer the most popular ones in class, or we can just talk about the homework in general. And also we're going to look into some libraries. So libraries are pre-made contracts made by people that are much smarter than you and I. And these are contracts that they're kind of like fundamental building blocks, like who controls your contract, like the question of ownership, the question of if something bad happens, are you able to pause it, that kind of stuff, right? And in week 15, this is less related to your homework, but I just wanted to show you guys how you can create your own token. The next, I can't use that word, but S something coin, right? Your next S coin. So you can create that, or your next NFT. Maybe it's just like a picture of an ape, or maybe it's your selfie. You can sell it for 10 ETH and see if anyone tries to buy an OpenSea. So and also we're going to learn about how to work with different token interfaces, how to interact with tokens from your contract, right? And week 16, this is a little bit more meta. So we're going to talk about decision making in the Web3 world, right? So what are DAOs? You hear the word all the time, but what is that? What is it really? And how does community governance work? And this is more or less into the business or community side of things, right? And then we're going to cover, if we have time, right? So if we have time, we're going to go over some advanced topics. So basically, how can we index the blockchain? Because scanning the blockchain is very slow, but there are services out there such as the Graph that they have basically they monitor the blockchain in real time, and they build out their own decentralized database. And then when you want to get some information from the blockchain, you basically go through them, and that only takes them like less than 1 second to respond. Whereas if you try to query the blockchain on your own, it might take anywhere from like 30 seconds to like 10 minutes. And also we're going to talk about how to use chaining price feeds if you're trying to build like a DEX, decentralized exchange or something. And also we're going to tackle how to store data on IPFS, pros and cons. And at last we're going to talk about using the Alchemy gateway as a way to basically have your own private gateway onto the blockchain. Mike is dropping some non-financial advice in the chat. Don't worry too much about it. And also, so homework 7 is due right before the week of the finals, and we're going to dedicate a class to reviewing for that. And then, or maybe I actually don't think that's like a review day, but I'm going to hold a quote unquote lecture review session regardless. So you all can come in and ask questions. And then we're going to have our final exam. All right, so there's that. Any questions on the syllabus? All right, perfect. Okay, so after we've talked about the syllabus, let's talk about the supplementary syllabus. All right, what a nice cover. Okay, so this is something that I wrote. So anything too complicated, but just as important, will be published here. This link is both in the syllabus folder and in the syllabus. I blasted the link everywhere to make sure that everyone can see it. So first, programming basics, blah, blah, blah. I strongly recommend you to watch it. We already went over that. And this version control, basically how to use GitHub, giving you a lot of videos on how to do that. And when you register on GitHub, you can actually get the student developer pack for free with your EDU email. So it includes a lot of free perks that are usually paid. And this is the more important things, right? So establishing a development environment. So if you're a Windows user, you can run a virtual machine on your computer that runs a pre-made Linux image that I made for development. And I have all the instructions here. And if you're a Mac user, you can also use it, although the best, we don't talk about VirtualBox because it's terrible. All CS majors know that. It's free, but it's terrible. And the only decent virtual machine software on macOS is Parallels Desktop, but it is paid. So, I'm not forcing everyone to use it. But if you do have it, or you somehow get it for free, I don't want to ask you how you're going to get it for free. But if you do somehow manage to get it, you can still use this image and run everything in the VM. Right, I have all the files ready. Why is it jumping? I have all the files ready here. Just follow the instructions. It's very straightforward. You're going to boot into it, and I have everything already set up for you. All right, and for macOS users, I have different instructions that you can follow. Right, and yeah, this is just more or less tutorials and what you should do. And for homework 0, right? Basically, homework 0 is due 2 weeks later. It's just setting up the environment, and I want you to run some commands just to show me that you have everything set up properly. And also, I want you to kind of learn how to use GitHub. It's really not that hard. You don't have to know everything about it. You just have to know how to get code from GitHub, make changes, and then submit the changes. That's all you need to know. It's relatively easy once you look into it. And also, again, watch the programming videos for your own benefit. All right. Any questions?
Yeah, I had a quick question.
Yes.
I was wondering if having an M1 chip and a Mac is gonna affect any of the programming we do in any way, if you know that about.
Great question. It will not, because I built each sign using the M1 Mac.
Oh, perfect. Great to hear. Great to hear.
I am on it right now. It's very good. I have the Air 13-inch. Perfect.
Sounds good.
Yes. Any other questions for me before we get into review? And once we get into the review, you guys will be doing most of the talking, because I want you guys to tell me what blockchain is. You know, when you're younger, when you're in elementary school, at least that's what happened to me in China. So so whenever we're doing review, our teacher would pretend that they just forgot everything and then, oh, can someone help me? So that's what I'm gonna do. So you're gonna have to tell me all about Bitcoin, because I lost my memory. All right, so let's get started on Bitcoin blockchain review. Right. So this is what we're gonna go over. So first, what is the blockchain? The blockchain is, and this all should look more or less familiar to you because you already took 256. So I'll kind of go through them relatively quickly. It's just a refresher on memory. But if you have any questions, just feel free to stop me, raise your hand, yell out, whatever. All right. Don't hesitate to stop me. The dumbest question is the one that's never asked. Is that how you say it? The point I'm trying to make is that there are no stupid questions. All right. I totally failed on that one. Okay, so what is the blockchain, right? So the blockchain is you can think of it as a distributed peer-to-peer ledger of digital transactions. So we can compare the physical ledger book to the entire blockchain. A ledger book is an accounting book where you kind of mark incoming and outgoing funds, right? So we can compare the physical ledger book to the entire blockchain. We can compare the pages in the ledger book that's comparable to a single block. And entries, and every single entry on a single page, we can think of them as transactions. Entries like Alice sent Bob 5 Bitcoin, 0.5 Bitcoin. All right, so entries make up pages. And you know, I'm just going to read through this real quick because it should all be, there's really nothing more to talk about. So entries make up pages, which make up the physical book. Transactions make up books, which make up the blockchain, right? And one of the key things about the blockchain is that nothing can be erased. You can only add to it. You cannot modify the past. I want to say that with a disclaimer, because sometimes you can, but only if you have the majority of the computing power. And everyone agrees and keeps the same copy of the ledger book. All right. So how does that work? So we talked about, you know, transactions make up the block and blocks make up the chain. So then how are transactions turned into a block, right? So every block has something called a block size limit. So that limits the size of the block, right? And that's determined by the protocol. So I think sometimes that can be agreed upon by the community. Other times it's a software thing. It's a hard-coded software thing, right? So why do you have a limit? Because we have limited data storage, right? Because every single node keeps a copy of the blockchain. So you know, let's say you're running a node, your computer, like your storage space isn't free, right? And it's limited. You can't just let the blockchain grow uncontrollably, because otherwise it's not gonna fit on anyone's computers. So there's limited data storage, and also because propagating data over the internet, especially, you know, if you want to maximize decentralization, and this is actually what Bitcoin did, right? The reason why Bitcoin had such small block sizes back then, and still even to today, of course, back then it was because internet in 2008, it wasn't as fast or as reliable as the internet today. So people had weak connections, drop connections. So they really had to limit the block size to make it so that you can actually make this protocol, make this decentralized protocol work for everyone involved, right? And nowadays they're just clinging onto it because it was Satoshi's vision. And of course, I'm not talking about Bitcoin Satoshi vision. That's an entirely different story. But because we have limited storage, the miners, they need to prioritize, right? They need to think about, okay, who should I, like, if I have if I only have 2 slots, but then I have like 10 people lining up for it, then how can I choose, right? How do I pick 2 people out of 10 to put into the slots? So so that's where transaction fee comes in, right? So with every transaction, in Bitcoin, you implicitly pay a transaction fee. That's basically the difference between input and output, right? So you implicitly pay that to the miners. And of course, miners being, we're being in a capitalist society, but miners, their purpose is to maximize profit, right? So to maximize profit, obviously the way to do that is to pick the transactions that gives the highest fees, right? And all right, so that's how basically that's how miners select transactions to be put inside a block. Now, can someone tell me what else goes into a block aside from transactions? Basically, we're going to talk about the block header, more or less. Yes, you don't have to tell me because I just showed you, but does anyone want to kind of give me a brief kind of definition or whatever explanation of each of the terms? So who wants to talk about what is a nonce? Does anyone remember?
Yeah, the nonce is, I guess, the solution to the proof of work. So the computer needs to find a nonce such that it produces the number of zeros in the target, I think.
Yes. So it's just something that we change in order to because it's a brute force numbers game. We're just trying to get to a certain number, and we don't know how to get there because everything is more or less randomized. We can't predict the future, so we just have to keep changing things in order to get the right hash. Now let's go back to this, right? So can someone explain to me what is hashing? Anyone from 256? I mean, you're all from 256. All right, JJ, let's go.
Hashing is basically turning a string, like some string that you want, into something else that is not distinguishable. And the issue is like it's hidden, but sometimes you might get, like, it's possible for you to get 2 strings where you turn into the hash and the hash is the same, but it's really unlikely.
And that's called C. Collision.
I forgot. Collision.
Yes, no worries. Thank you. And anyone want to, so that was a great explanation, right? So basically it turns a string or any input data into an output of fixed length. So it doesn't matter how long the input is, the output will always be of the same length. And also it's irreversible. So meaning that you can only go from the input to the output. You can't go from the output to the input. And also it's deterministic. So every time you hash the same input, it will always give you the same output, but also it's unpredictable because as we can see here in this example, so the red fox jumps over the blue dog, right? And then this is the hash that it gives you. But then if we just change one letter from V to U, the hash is completely different. And there's no way at all that you could have predicted that. And if we switch V and E in over, it produces an entirely different hash. So it's unpredictable, but it is deterministic, right? But it's completely random and there's no way to go back. Because if you think about it, if let's say any input data can be when it goes through hashing, it becomes an output data of the same length. If you hash the entire everything written by Shakespeare and it gives you like an output data of this length, how are you gonna go back, right? There's a significant, tremendous loss of data when it goes through the process and you just can't go back, right? So that's hashing, and that's how nonces work because you can see here, every time we change a tiny bit of the input data, the output completely changes. And for the nonce, and we're gonna go over this in a bit. So basically, we're basically trying to come up with the block hash that's under a certain difficulty limit in order to basically, that's the rules. And you don't know when it's going to happen. You don't know how you can kind of manipulate the input to make it so that the output has a certain number of leading zeros or like smaller than a certain value. So you just have to keep trying. And in order to keep trying, you have to change something because it's deterministic. So if you hash the same input, you're always going to get the same output. So what do you change? So there's 4-byte nonce, right? So you change that to make a tiny change in the data so that the output hash is completely different, and you hope that it's the one that you're looking for. Now, the nonce has a fixed length, meaning that there are only so many ways you can change input data. Now, if you run out of nonce, then what you can do is you can alter the timestamp, right? So you can alter it by like 1 second or something, and then now you have like all the nonce, basically you can reuse them again, right? Okay, so how are blocks connected, right? So inside the block header, the hash of the previous block is stored, right? So this is what it uses to go back. In computer science, we call it a linked list, right? But it's basically, yeah, so imagine the blockchain as a book, right? So it's not page numbers, we have hashes. And imagine all the pages, they're not consecutive in a sense. So they only have hash numbers on them. And then they also have the numbers of the hash of the previous page, more or less. So the only way for you to get to the previous page is to find the other page with the matching hash, right? So we already talked about what are the properties of a SHA-256 hash. We talked about it. And can anyone tell me what happens if the block is tampered with? So something's changed.
Won't the hash be different, like the output of the hash?
Yes, that is correct. And the implications are in terms of the blocks being connected.
Wouldn't that block just be rejected? The one that's tampered?
Yes, so if you go into the past and change the past, right? If you go to the past and change the past, then let's say you're trying to go 10 blocks back and change something. And when you change something, the hash of that block is going to change, right? So when the hash of that block changes, then the next block is still pointing to the previous hash. So then everything behind it basically gets disconnected. And if you want to catch up, you have to redo the proof of work for every single block afterwards to recalculate the hash. And by yourself, you will never ever catch up. You can only catch up if you have more than 50% of the available hash power, and that still takes a while because you're essentially creating a fork, more or less. So it's incredibly expensive to do a network takeover, and Bitcoin is actually, I would argue, the most secure network in the world, especially now that China has banned mining. And also, I believe Bitcoin is the only network in the world that's had 100% uptime, no downtimes. Remember in the past couple of years, we had a few Amazon AWS outages where half of the websites that you visited weren't working, or that time when Facebook completely crapped their pants and nothing worked. It was hilarious when Facebook, when their servers, when their DNS stuff broke down. Apparently, their technicians couldn't get into the server room because their key cards won't work. Yeah, so Bitcoin, I believe, is the network with the highest uptime, 100%, and that's the power of decentralization. Of course, among other powers such as horrendous gas fees, but that we don't talk about that. So this is a visualization of kind of the blockchain, more or less. So you can see that every block has we call it a hash pointer in computer science, but it's basically a hash that points to the previous block, right? And up until the genesis block, the genesis block is the first block ever, so there are no previous blocks, so it doesn't point to anything, right? And in the block, we have block headers, block data, all that kind of stuff. right? So this is another visualization. The block height, meaning, actually, I'm going to ask you guys, what is the block height? Yes, JJ, just go ahead. Don't worry. Just start talking.
Oh, it's just how many blocks there have been, right?
Yes. Yes, that is correct. Yes. And in the header, we have, the previous block header hash. It's, yes, Mike, that is correct. We have the timestamp, difficulty, nonce, and something called a Merkle root. Does anyone remember what are Merkle, what's the Merkle root and what are Merkle trees? And hint, it's not the what is it? Germany's chancellor or something. It's not her. It's not Angela Merkel next to the tree. It's something else.
The Merkle rule was if I remember correctly, like the fingerprint, the hash of the summary of the transactions. So it was like a fingerprint of all the transactions.
Yes, that is correct. So we basically pair up transactions. Pair them up in pairs, and then we hash the pairs, and then we hash the hashes of the pairs, and then we do that, and we kind of reach the top, and the very top hash, the root is the Merkle root, and the entire thing is called a Merkle tree. And what is it used for? Does anyone remember? It's used to prove something. To quickly prove.
Oh, it's used to prove that a transaction was in a specific block.
Yes.
Merkle trees are like a specific type of data structure where you can tell based off the root, like if that transaction belongs in that.
Yes. Prove membership. Yes, Maya. And the reason why it's so quick is because to prove some transaction is in the block, all you need are the hashes leading up to the Merkle root. You don't need all the transactions, right? So you just need to find a path, and then you get the adjacent hashes, and then you kind of prove them like that. So it's much faster than trying to hash everything from scratch and doing verification that way. It's also less network intensive. So, we have to think in terms of networks. And if you're running a light client and you're trying to prove something, you don't have to download everything, right? So a light client means that a client that doesn't save the entire blockchain, like your phone wallet or something, right? So, and then afterwards, we have like transactions, right? So now, how are blocks propagated? Does anyone remember what gossip protocol is? Those who speak shall receive 1 ETH from the testnet. Testnet.
Oh, isn't it the way that the network verifies that like a transaction is legitimate? So like one node says to the other, like, hey, I got this transaction, did you get it? And then they verify it and they pass it on, and that's how consensus is reached.
That's not how consensus is reached, but it is how transactions are spread through the network. Let's say you sign a transaction saying that you're going to send me 10 Bitcoin, right? And once you do that, you basically you blast it to all the nodes that you're connected to. Now, I forgot if this is Bitcoin or Ethereum, but I remember at any time, your node is connected to around 12, 13 other nodes. So you kind of branch out like that. And after 2 or 3 or 4 iterations, you basically reached everyone, right? So everyone that receives your message blasts it out to 10 other people. And the magnitude of that grows very, very quickly, right? So, but actually gossip protocol is actually outdated because apparently it was too easy to track where the message was coming from. So they now use something called diffusion. So it's the same as gossip, it just adds random delays. So you're not blasting the 10 people at once. you're randomly delaying, when you're sending this to like to some node. So you're basically introducing a random messaging delay. Sadly, people also found a way to break through this and find out who's the where this transaction originated from. But let's see if we can play this. Yes. So okay. I will stop talking, and we can watch this. So you see, it randomly delays or is it doing that? It is. Yes. So it's a random delay, and you can see that the power of the decentralized network, right? So let's say there are only 100 nodes in the world. Although you can see, you say that, if I blast it to 10 people and then those 10 people blast it to 10 other people, I can reach 100 really easily. But the thing is, sometimes maybe it could be a connection problem, it could be this or that, like they're not easy to reach, right? Because if you ever tried playing online games with your friends from another continent, especially shooter games, it's not fun playing with 200 milliseconds of ping, right? And then you disconnect halfway. No, you disconnect right before you're about to win. That's usually what happens. So it's the same thing with nodes, right? But in the decentralized network, actually, the more nodes there are, the better the network performs. You can see here by the propagation delay history, right? So this is basically this is a measurement of how laggy the Bitcoin network is. So how quickly or slowly a transaction originating from anywhere gets propagated to the entire network. And you can see that as the years go on, and as more and more nodes join the network, you're going to see the delay getting less and less. So I thought that was pretty cool, right? You can see the network at work, more or less, the power of the decentralized network, and also the storing gas fees whenever there's demand, right?
Is that because the network is like more spread out by the nodes?
That too, but also just because when you have more people, it's more or less of a paradox, because when you have more people, then obviously it's going to take longer to reach everyone, but then it's also quicker because people are more connected. So you can see like the paradox here. But I think in the real world, with all the different factors like network delays and whatnot, the more expansive the Bitcoin network is, the faster it is to propagate. And you can see that we've more or less reached a plateau here, right? It's not going to get much faster.
All right, got it.
Yeah. All right, so let's talk about how consensus is formed. It's formed, right? So we have something called a miner. I totally went I didn't talk about this, but what are miners? Someone tell me what miners are. And these are all reviewed. There are no trick questions, all right? So anyone can talk about this. Anyone know what a miner is? What you're thinking is probably correct.
I mean, it's a special node that just keeps a record of the whole blockchain and is responsible for putting transactions into blocks. And then
yes.
Blockchain, yeah.
Yeah, so they're full nodes that are in charge of validating transactions and also creating blocks, right? And proof of work, we briefly talked about it when we were talking about hashing and nonce. Can someone give me like a holistic definition of it? Not holistic, but a definition of how proof of work works with in terms of difficulty in hashing. Anyone brave enough? That's okay. I will be the brave one. So proof of work, the way it works is that so basically when everyone has basically filled their blocks more or less, right? How do you because everyone gets transactions, every miner receives transactions in different orders because they're physically in different locations, and there are network delays and whatnot. So they put different transactions into their blocks, and in different order too sometimes. So how does the network decide who to listen to, right? When you have so many nodes out there, how do we decide who to listen to? So we use something called proof of work, and this is not only to build consensus, but to also secure the network, right? So the way it works is that after you put all the transactions in the block and you basically lock down everything in the block, all the other pieces of information, right? The network has something called the difficulty target or the difficulty or something, right? So the difficulty, as you can see here, is basically, you can think of it as a requirement for the hash that you generate, right? So let's say when the difficulty is 4, now this is just for illustration purposes, but if the difficulty is 4, then it has, so the hash that you generate must have 4 leading zeros, right? Now hashes are fundamentally numbers, right? So essentially what this is saying is that the number that you generate must be smaller than this difficulty thing, right? It's kind of like you're trying to walk under a horizontal bar, and the lower the bar is, the harder it is for you to walk underneath of it, right? So that's how difficulty works. So the more leading zeros there are, the smaller the acceptable range is. And because SHA-256, it's unpredictable, remember, it's not predictable. So you don't know how you can get to a certain hash. So all you can do is to keep trying and keep brute forcing it until you get the correct result, right? And this basically incurs a huge computational task, right? And the reason, and whoever finds it first will basically be the de facto standard of the network. So that would be the block that everyone else has to conform to. That would be the next block that gets appended onto the chain. So whoever finds it first, right? And then the other property of hashing is that to get to a certain hash, you have to brute force it. But to verify that something is a hash of something else, it's very easy, right? You just run it through the algorithm once and you got it. But when you try to get to a certain hash, it's very difficult to brute force. So it's slow to produce. It's slow to produce, but it's very, very quick to get verified, to be verified, right? So once you produce a hash that fits the difficulty, then all you need to do is to tell the others, okay, I figured this out. You can try to verify it, and they only have to run it once to verify that your hash is valid, as under the difficulty, and then and then everyone else will start to listen to you. And whoever finds, and the reason why people race to find that is, what do miners get when they're the first to figure out the hash of when they're the first to kind of figure out the hash that fits the difficulty? What do they get? What's their incentive? Anyone remember? Yes, Selena, that is correct. So block rewards, right? So whoever figures out the puzzle first gets a block reward. And that reward, it started off as 50 Bitcoin. That's when Satoshi first started mining that in 2008. What is it right now? Is it 12.5 or has it been halved again? I forgot. But it halves every roughly, I think 2,000 blocks or so. Or no, that's a difficulty adjustment. I think it halves roughly every 4 years, and that eventually tapers off. Eventually, it's going to get halved to a number so small it's smaller than the minimal kind of the smallest decimal in Bitcoin, and that would basically signal the end of the Bitcoin issuance. And remember, there are only 2 ways to get Bitcoin. What are they?
Mine it yourself or get it from somebody else?
Yes, so you can only mine yourself or you get it from someone else, right? So miner rewards is basically how Bitcoin bootstraps the network. And that's also how the circulation is, how the supply is increased, and it tapers off at 21 million. All right. Now, how does doing all this make tampering past data very difficult? Well, because you have to redo all the calculation, right? And if you don't have at least half of the network mining computational power, it simply means that you're never going to catch up, right? And also the difficulty, and how does it relate to the block time, if anyone remembers? What is the block time at Bitcoin? So the time it takes to mine a single block, what is roughly the average? Does anyone remember?
Was it 10?
Yes.
It was 10?
It is 10 minutes. Yes. It's around 10, 12 minutes. Sometimes you get the unicorn like 5 minutes, 2 minutes, but it's not very common. It just means they had really good luck. And yeah, so how do you think difficulty relates to block time, or how does it controls block time?
If it takes longer for someone to mine a block, if it takes longer than 10 minutes, the difficulty decreases to get it near that 10-minute point. And if it takes less time, like 8 minutes, the difficulty will be increased.
Yes. So difficulty is actually dynamically adjusted by the network, right? So it tries to keep the block time at around 10 minutes. And if there's a significant computational drop off, such as China banning all miners, then the difficulty will stay the same for a little while, but then they would see that everyone's taking too long to mine the blocks. So it would then drop the difficulty down in order to keep the block time at around 10 minutes. Right now, if there's a significant influx of computational power and the block time's too low, then it will increase the difficulty, meaning adding more zeros in front, just so that the puzzle is tougher, right? So it takes longer at around. So it tries to stabilize itself at 10 minutes, right? Now we also have the longest chain rule. Does anyone remember how this Bitcoin guard against double spend? Now, what is double spend? Can anyone tell me? Double spend. All right, I will tell you. That's fine. So, I have some in the chat. Yes, Mackenzie. When someone tries to use the same block, well, not necessarily the same block, right? It's more like the same amount of the same U2XO in Bitcoin, right? It doesn't happen in real life because you cannot say I'm going to double spend a single bill of cash, right? If I have $100 and I give it to you, then it's physically removed from my ownership. I can't give it to anyone else because I don't have it. But in the computer world, what's stopping me from like for the lack of a better term, copy and pasting some digital Bitcoin and then just spending it elsewhere, right? Now, that's, we all know, how easy it is to pirate stuff, to download software, movies, whatever, illegally, right? To make illegal copies. Then how can we prevent the double spend of the currency if it's purely digital, right? So that's where the longest chain rule comes into play, right? So this is how you're going to double spend. So the way you double spend is that you basically, let's say you're trying to buy a Lambo with your Bitcoin gains, right? Because that's what everyone does when Bitcoin hits $1 million, right? To buy a Lambo, probably a lime green one that's very obnoxious. But so let's say you want to scam the Lamborghini dealership, right? You want to pay them Bitcoin, you want to scam them, right? So what you do, so this is how you do it, right? If you have the resources, you could. But by the time you have the resources, it's probably not worth it to scam them. But let's say you want to scam them just to spite them, despite this one particular Lambo dealership, right? Maybe when Bitcoin was $10,000, they thought you were too poor and they didn't treat you well. Now it's $1 million. Now you're trying to buy a Lambo, and they have to treat you better. But anyhow, so the way you do it is, so first you transfer $1 million of Bitcoin, or how much is Lambo? I think it's a Huracan is like $350K in Bitcoin. You give it to them, right? You transfer it to them on the green chain. And what you do is you build a second chain that doesn't include that transaction. All right, and you mine it in secret. So usually what happens if you find an X block, you broadcast it to everyone, right? So that everyone knows you've mined an X block, so that they can all conform to your block. But because you want to screw this dealer in particular, you start building your own stuff in private, and you don't tell anyone, right? And this means that you must have enough computational power to be faster than the public chain. So you build your own chains in secret, and when you overtake the truthful chain, you suddenly tell everyone, oh, like I have all these blocks mined, and now I'm ahead of everyone, so everyone has to listen to me. And this is the longest chain rule, right? Now, if you can successfully do this, so basically the longest chain rule is that the entire network, the absolute truth is basically whoever that has the longest chain. That's who everyone listens to. Now you can say that, okay, it's easy enough, right? I can just scan that dealership, using this longest chain rule. But you have to remember, you need to have enough computational power to overpower literally everyone else on the Bitcoin network on Earth to scam this one dealership. And it's probably going to take you more than $350K to acquire all that computational power. So the point is, it's a game theory where by the time you could scam someone, it's probably not worth it to scam that person. It's probably better to just play by the rules and get all the block rewards that way, right? So it's an incentive issue. Now, of course, if you're just too rich, then no one can stop you from doing anything, right? If you're too rich and you have an irrational hatred against this dealership, then you can do that. But you're severely incentivized to not do it. You're heavily incentivized to not do it, all right? So this is the longest chain rule. Does anyone have any questions on this one? So by the time you announce that your chain is valid and everyone listens to you, the Lambo dealership will find that the transaction where you paid the dealership in Bitcoin never happened because you never included it in any block. So now they got scammed out of their money. You have your Lambo. So that's how it works. Any questions? I assume no questions. Yes. All right, so let's move on. So what is a digital signature? Does anyone remember? What is a private key? Let's start from that. What is a private key at its fundamental what is the fundamental definition of a private key? A private key is just a really large number, right? So a private key is just a huge number that's randomly generated, right? And a public key is a mathematical derivative of the private key, right? And then we do that with the ECDSA curve or something. Anyone remember what is ECDSA? Like what's the ECDSA is the acronym. What's the full phrase?
Oh, I don't know what the full phrase is, but I remember it being, it's this like elliptical line that's graphed and like there's like a point. I think it's like the vertex of the parabola is like the solution to the key, but I guess Jared can answer.
I was just gonna say what it stood for, which is elliptical curve digital signing algorithm.
Yes.
And what Cameron I think was saying is like you take wherever that private key is, and then on the curve, and then you draw a tangent line, and then you reflect it, and then you multiply it however many times.
Private key times.
Private key times, yeah. and then you end up with the public address. Yeah.
A public key,
Public
not
key.
necessarily public address,
Yeah.
right? So there's a difference. So yes, so that's a great point. So what is the difference between a public key and a public address? Anyone remember? So the public key, the public address is the hash of the public key. I don't know why Satoshi did it, but that's what it is, right? And you don't ask people for their public keys, you ask for their public addresses, right? So you can think of the private key as your email and password combo, where only you should know. So only you should know what it is. Whereas your public key, or I guess public address, is like your email that you tell everyone so they can send you stuff, right? So you see, private key goes through an elliptic curve multiplication, which is one way. It's not strictly one way, but it's impossible to reverse. It takes way too much computational power to reverse. It's just not practical. So it's a one-way thing, and then the public key, when it gets hashed, I think hashed twice to become the public address, which is also one way. All right. So then, what is a digital signature then? Right. So I say that digital signature is used to prove the consent of a certain entity. Now, what does that mean? What does it mean when I'm trying to verify your digital signature of a message or of something? And what do I need in order to verify it? I mean, it's already on the slides, but.
Well, aren't you trying to show that that person they're the right person to spend that UTXO?
Yes, but more in general, in the case of digital signatures, when you give me, so what does it mean when I'm trying to verify your digital signature? What does that mean? I'm trying to prove your ownership of
The private key that's signed that?
Yes. So I'm trying to prove your ownership of the private key, right? So you sign that message, you signed a certain message using a private key, and then I can verify that you signed it with your private key using your public key, right? So it's a way to prove that you really own your private key, because I know that in order to generate this signature, you must have used the private key that's associated with this public key that I'm using to verify it with. Does it make sense to everyone? Yeah, so you can see here, we have some plain text. We sign it with the private key, it generates the digital signature. And then to verify it, we need the public key and the message. So, and then if the signature is valid, then we know that the person who claims to have the private key of this public key and who claims to have signed this really did sign this with their private key, right? Now, in Bitcoin, I think it's, I don't think it's, so in Ethereum, there's actually something called, in Solidity, there's a function called EC recover. So you can, so what it does is it recovers. So given the original message and the digital signature, it recovers the public key of the signing entity. And if the public key that's recovered matches the public key that whoever claims to own the private key of, then you know that this person is telling the truth. So, and in Ethereum, if it's not valid, then it's just going to recover, it's just going to give a completely different public key, right? And then you'll see that it's a mismatch and you know that person's lying, right? So in Bitcoin, a digital signature is used to prove that that some transaction is indeed authorized by the sender. All right. So let's say, so it's €5, but whatever. So it's a UTXO or something, right? So the owner signs it with the private key, right? So and then the private key, and then we send it to someone, and they can basically verify if the signature is valid using their public key. Now, because why can we do that? Because there is a mathematical relationship between the private key and the public key. So that's why we can verify it like that, right? All right. Anyone remember this question from the final in 256 or the midterm? Or I think that's the final. Walk me through what happens when I send you 1 Bitcoin. I'm not going to show the next slide. Who wants to be, is anyone brave enough to recall this piece of traumatic memory? I don't think that's that traumatic because it was open book, but. Okay, that's okay. It's a tough one. All right. So let's go through this. All right. So first, the transaction is created and signed by me, right? So, and the transaction is I'm sending you 1 Bitcoin. All right. And then the transaction is broadcasted through the Bitcoin network to the other nodes, which is the gossip protocol diffusion that we're talking about. Right. And to the individual nodes that we sent it to, they validate it. They validate the digital signature if it's valid. And if it is, then they propagate it even further. All right. And special nodes that are called miners, they validate a number of transactions and then pack them into a block. Right. And then they basically they sort based on transaction fees. And they basically skim off the top because it's a capitalist society. Right. They skim off the top, take the ones with the most fees because that's going to be most profitable to them. They pack it into a block, and then they solve this math puzzle, the guessing game, which is called proof of work, right? And then now, if the miner succeeds in finding a block, in finding the next block, then it will broadcast a new block and then adds it to a chain. And then the other people, they all just verify if the block that was broadcasted to them is valid, just by hashing it once to verify if the hash is correct and meets the difficulty target. And if it does, then they drop what they're doing and then they add this block to the chain. It's whatever they're working on, right? So the first miner to do so wins because the first miner to find out to mine the next block will be the longest chain. Will have the longest chain in the system, longer by 1. All right. So all the other people will have to listen to them, right? And then now everyone in the network knows that I have sent you 1 Bitcoin, right? So everyone is now on the same page. The block has propagated and everyone's on the same page now. I have given you 1 Bitcoin. And then, everyone starts over trying to go for the next block. All right, does that make sense more or less? Does that not make sense more or less? Yes. I'll have to start asking the opposite question. Does it not make sense more or less? Okay, I'm assuming it makes sense. And you see that I haven't talked too much about UTXOs because Ethereum uses a different system. And we're not going to kind of talk about UTXOs too much this time. All right. Okay, so why do you use blockchain? So when you're trying to build a product, why do you want to use blockchain except for, besides slapping the word blockchain onto your brochure and then making it appreciate in value by 2 times instantly? Why do you use blockchain? What are some industries that can benefit from blockchain use? So just as a refresher, we talked about a transcript verifier thing in 256, right? Yeah, go ahead. You don't have to raise your hand. You can just go ahead and talk, Chase.
Anything with logistics with the auditability version of it. So with food and restaurants from like fisherman to table.
Yes, that's a great use case in IBM. I think IBM, Walmart, they're doing that. JJ, you raised your hand.
Yeah, I was going to say the same thing as Chase, just anything that requires a certain level of transparency. Like one thing that I can think of is like diamond mining or something that's controversial.
What mining?
Diamond mining.
Diamond mining, yes. Yeah, that makes sense. So anything requiring a paper trail, more or less. And also because in the blockchain system, especially in the public blockchain system, it's not like you can just bribe someone to change records, right? So it's a decentralized. So basically, you can't bribe anyone. You can't change the past. So the paper trail can be trusted, right? Proof of ownership. Yes, that too. Some people now are doing real estate on the blockchain. Not talking about the metaverse, of course, where a single land parcel is like 20 ETH. I think that's insane. But the more interesting thing is they're probably going to appreciate, not financial advice, but that's just how it is, right? So immutable, so the properties are immutable, transparent, decentralized, cryptographically secure, right? So the great thing is that you don't have to trust any human, more or less, okay? There's a disclaimer. So you don't have to trust a human more or less. Once the data is on chain, you don't have to trust a human. So actually some brands also use the blockchain for product verification to see if it's genuine or fake or counterfeit, right? But the blockchain is not the answer to everything. So if you were around in 2017, 2018, you'll remember that every single startup or whatever, they had to slap the word blockchain onto their pitch deck or whatever. Everything suddenly, you know, this toilet is blockchain enabled. It's probably not that, but everything was blockchain. But blockchain is not the answer to everything, because although blockchain has these positive qualities, more or less, they also have these positive qualities also introduce a lot of downsides. Let's say everything's immutable, right? What if, you know, so there's actually this file storage blockchain called Arweave. So instead of storing data, instead of doing monetary transactions, which it also does, I guess the blockchain itself is built for file storage. So storing images, documents, videos, it's immutable. Sure, it's very good. What if there's child porn? How are you gonna, right? It's gonna be up there. It's gonna be immutable. What are you gonna do about it, right? Now that's going to go into censoring, doing collective censorship by the nodes. Everyone has to agree on to not, you know, to not respond to this request, but it's still out there, right? You can run your own node and bypass that. So, right, when something that's not just illegal but ethically, it's not even ethically questionable, it's just ethically bad, gets onto the blockchain and it's immutable, how are you going to deal with it, right? And it's transparent. Well, what if you want to do something in private, but you want the other qualities, but you also want a private transaction, but it's impossible on the blockchain, more or less. Right now, there are like zero knowledge proofs or privacy chains like Monero, if anyone's heard of it. Has anyone heard of Monero? Please raise your hand if you've heard of it. No one's heard of Monero. That's okay. So Mike Ma, yes. Jacob, you want to briefly talk about what Monero is?
I'm not sure if I give the best description, but correct me if I'm wrong. Yeah, one of the main differences between a chain like Monero versus Bitcoin is that you can't necessarily see the address of who sent the Monero coin to another person. That's like all, it's all private. It's a private chain, so you can't see who's sending money or where, and go back and like retrace steps, like almost like that paper trail, like you can on Bitcoin. You can see where every Bitcoin has been, or you know what address has what, how much Bitcoin, etc. Is that correct?
Yeah, that is correct. So everything on Monero, it's private. So I actually haven't used it, but I think you can prove that something happened if you have the necessary information. I think, I'm not too sure. Don't quote me on this, but basically, yeah, if you go to a Monero block explorer, everything's in question marks because nobody knows. It's all private. And at the NSA, actually, it's had a bounty, and it's actually a lot of money to reward anyone that can crack the Monero chain. And the bounty's been up there for 2 years, and no one's cracked it yet. So basically, it's very, very private. It's very secure. No one knows what's happening. But that also brings some issues like, you know, money laundering or, you know, that kind of stuff. You can't trace it, right? And also decentralization, right? So what are the downsides of decentralization? Anyone want to take a jab?
Scalability.
Yeah. What in particular?
So like, say if you like build a D app, right? And then, for instance, you want to store like a large amount of user data on Ethereum, but since each interaction with smart contracts costs a lot of gas fees on ETH, basically once you, and per node on ETH only can process 10. So if Ethereum, you can only process 10 to 15 transactions per second. So with a large amount of users, your gas fee is gonna go skyrocket. That's why you're seeing, ETH gas goes to $300, $400 with one single transaction on DeFi platforms. And so it's not very user friendly for, end user applications such as, something like a signature signing or something. So yeah.
Yeah, that's totally correct. So one issue with decentralization is that it takes time to form consensus and for everyone to agree on something, for everyone to be on the same page, right? And so performance is an issue for decentralized systems, right? Centralized system like Amazon or whatever, the performance is super fast. Why? Because they listen to a central authority, and you only have to make the deal. They just automatically agree to the central authority. They just copy whatever the central server does, right? They have like CDN servers or other servers that basically just listen to whatever the central server does. But in a decentralized system, there's a lot of negotiation in the form of proof of work stuff, for example, or just propagation, where when every peer is equal, there's no one to listen to. Right? Instead of a central authority, you just have to send a transaction to a central server and all the other servers just listen to it, right? Super fast. So decentralized system has a performance issue, right? So these are some of the major downsides to blockchain technology. So every time when someone asks me, should I use blockchain in this? Should I use blockchain in that? I usually just, I just ask them like, does your project make good use of the positive attributes of blockchain, right? The positive properties. If not, then I think the negative side is too much, the downside is too much, and you're better sticking to Google, Amazon. And all the major networks, they're still sticking, the internet as we know it, right? The one that we're using right now, we're all on centralized servers. And it's not working out too bad. I mean, YouTube demonetizes people, but that's an issue with the centralized platform. But for the most part, it's working okay, right? Like you don't go on Reddit and complain that Reddit's not decentralized because it works just fine, right? So my advice is in terms of entrepreneurship or development stuff, if you can't make good use of immutability, transparency, decentralization, or just a separation of responsibilities, basically if you can't make use of those properties, then I would advise you to not use blockchain. All right, so that's about it. That's just a quick review of a brief recap of 256. That's about it for today. We are 7 minutes early. It's pretty good timing. So I will stick around for 20 minutes for a little bit, I guess, after class if we want to talk about things. But otherwise, it's great to see everyone, and really excited this semester to teach you how to write your own dApps, and have a good rest of your day. Thank you.
Thanks, Jack.
Thanks, Jack.
Thanks, Jack.
Thank you.
Thank you, Jack.
Thanks so much.
Thank you.
Thank you.
Tremendous.
When's the next blockchain USC meeting?
Mike?
We're probably gonna start like in February because January things kind of like we already have like we're supposed to host ABX. The school apparently like doesn't allow any in person until like end of month. So I
We were
think
supposed to host
that's where we
AVEX?
start. Yeah.
Avalanche? Oh,
Avalanche.
that's a bummer.
Yeah, but they're still coming. I think it's just a different date. And I caught the coin list this morning, so they're coming at some point in February. Yeah, we have a lot of new speakers this semester.
Cool. Can't wait. Good to see you guys. Thanks a lot, Jack. I'm excited for this.
See you, Jacob.
See you, Jake.
Well, I actually have a quick question, Jack.
Yeah.
I already made an account earlier on Code Academy because I want to learn more about Solidity because in the past I have not been the best at coding.
Yeah.
But I was wondering if you had like any recommendations specifically on like different YouTube videos I could watch or channels.
There's something called Crypto Zombies that a lot of people seem to like. I haven't tried it, but it's pretty popular. You can try it out. I think Crypto Zombies is probably one of the better approaches, I think.
Okay.
But it's, you know, I will assume that everyone has no programming knowledge, but it'll be a lot easier to understand everything if you do. Like you'll get a lot more out of the class if you do. All right. And I honestly think as long as you understand the basic concepts of coding, like what are variables, what are functions, that kind of stuff, I think you're good to go. And then just do some Crypto Zombie stuff. I think you're more than ready.
Crypto Zombie. Okay. Thank you so much. Okay.
No
Have a
worries.
nice night.
Yeah, you too. Thank you. All right, cool. I will close this room and I shall leave.